Hi Arun, I hope you all watched the previous videos. Let's start the session. We are continuing the chapter 3, measuring device and tools. Okay, and that first question, which caliper is joined by rivet and washer? So that is fern joint. Okay, you can see here in the image. So you can observe this. This is the fern joint. Okay, so fern joint caliper works on the friction created at junction of the legs. Okay, and the two legs are identical in shape with the contact points equally distant from the fulcrum and are joined together by rivet and washer. Okay, the distance between the rivet center and extreme working ends of the legs is known as nominal size. Okay, so the distance between the rivet center, that is here. Okay, this is the rivet center, and the extreme working end, that is this point. Okay, this total length is called nominal size of the fin joint caliper. Okay, nominal size. Okay, what is meant by snap gauge? So options are which measures gauge length and which measures gauge width and thickness. Okay, and option C, which measures gauge outer diameter. So all of the above measurement. Okay, okay, all these three are possible. Okay, so snap gauge, you can see here in the image, this is the snap gauge. Okay, it is used to check external dimensions like length, width, thickness, and height, etc. Okay, and go and no go principles of gauging are that the go end of the gauge must go into the feature of the component being checked, and no go end must go into the same feature. Okay, which gauge is used for measuring hole? So that is plug gauge. Okay, you all know that, right? Plug gauge is used to check holes or internal dimensions. Okay, and go plug gauge checks minimum limit of a hole. No go plug gauge checks maximum limit of a hole. Okay, this is the plug gauge. Okay, so you can observe that go side and no go side, right? And basic size is mentioned in between the, I mean, at the center of the gauge. Okay, and tolerance is also given here, right? By which gauge external and internal radius of workpiece is measured. So that is radius gauge. Okay, option A. Okay, so you can see here, this is the radius gauge. Okay, and their parts. Okay, so you can observe this profile. Okay, that is convex, sorry, concave radius. Okay, and this profile, you can this is convex radius. Okay, so radius gauge is also known as fillet gauge. Okay, radius gauge or fillet gauge or fillet gauge. Okay, we have discussed it in previous classes. Okay, and radius gauge is used to measure external and internal radii of workpiece. Okay, it requires a bright light behind the object to be measured. Okay, by which gauge screw thread of pitch is measured. So that is screw pitch gauge. Okay, that is option C. You can see here in the image, that is the screw pitch gauge. Okay, it is used to check the pitch of external and internal threads. Okay, it is also used to compare the profile of thread. Okay, the angle of a drill is measured by which gauge? That is angle gauge. Okay, you can see here in the image. Okay, this is the angle gauge. This is how the angle of drill is measured. Okay, you can see that this should be coincide with the this side. Okay, and the angle would be measured like this. Okay, and the angle gauge is made of alloy steel. Okay, alloy steel. Okay, and the face of this gauge is a tap. Okay, it is used for measuring angle and to set the job on the table of machine and for measuring drill angle. Okay, name of the gauge for measuring external measurement or slot of workpiece. So options are limit gauge, vernier caliper, feeler gauge, option D, A and B. So here options are A and B. So both limit gauge and vernier caliper. Okay. So limit gauge and vernier caliper is used for measuring external measurement or slot of a workpiece. Okay. And limit gauge is used to ensure that the component lies within the permissible limit or not. Okay. And vernier caliper is a device used for measuring linear dimension. Okay. So a few examples I'm gonna show you here. So these are the different types of gauge. Okay, snap gauge, plug gauge, ring gauge, feeler gauge, dial gauge, scale ruler, bevel protractor, height gauge. Okay, few more are there in coming slides I will discuss. Okay, what is another name of slip gauge? So that is Johnson block gauge. Okay, so you can see these are the slip gauges of different dimensions. Okay. Slip gauge is also known as Johnson's block gauge. Okay, it's an important thing. So please remember this. And slip gauge is used as standard for precision length measurement. We know that, right? It is made in sets and consists of a number of hardened blocks made of high carbon steel with low thermal expansion. Okay, telescopic gauge is used for what? It is used for internal diameter of large hole. Okay. So you can see this is how the telescope gauge gonna work. Okay, you can see uh, this is the large hole. You can say this is the bore. Okay, and this is the telescopic rods. Two rods are there. Okay, and one handle. Okay, this is the handle. Okay, and one locking screw is there to lock the dimension of the bore. Okay. So it consists of a handle, two telescopic rods, and locking screw. Okay. So telescopic gauge is an indirect measuring device. We can't measure directly. Okay. It is used to measure the internal diameter of a bore, hole, groove, slots, etc. Okay. Which of the following gauge is used for checking threading tool of lathe at an angle of 60 degrees? So among the options, the answer is center gauge. Okay. Center gauge is the right answer. You can see here in the map, this is the center gauge. Okay. It is used to measure an included angle on tool bits that are used to cut threads. Okay. And it is made of spring steel, hardened and tempered, and is used for grinding and setting a single point thread cutting tool. Okay. Which grade from the following grades of slip gauge for the purpose of laboratory and standard? So that is option B. inspection grade. Okay, so these are the different types of grades we have discussed in previous class, right? Grade 0 is for calibration grade. Grade 00 is reference grade. Okay. Grade 1, that is inspection gauge. Okay. Grade 2 is for workshop grade. Okay. What is the measuring of gauge in the case of railway track? So that is distance between inner faces of two tracks. You can see here in the image. This is how it's gonna work. Okay. In the case of railway tracks, the distance between the inner faces of two tracks is measured by using gauge or by measuring the inside of two tracks by the gauge to make a rail track. Okay. Gauges for simple work are made of high carbon steel and after hardening and are made to correct size by grinding and lapping. Okay. Which gauge is used for checking internal threads? So that is screw pitch gauge, option C. Okay, this is the screw pitch gauge. It is used to check the pitch of external and internal threads, and it is also used to compare the profile of threads. Okay, gauge are indirect measuring instruments. Okay, so option B. Profile of gauge tooth is checked by using optical projector. Okay, you can see here in the image, this is the optical projector and this is how it gonna work. Okay, optical projector is widely used for inspection purpose. Okay, profile of gate tooth is checked by it, we know that. Okay, and you can see how it works. It projects a two-dimensional magnified image of the workpiece onto a viewing screen to facilitate measurement. Okay, this is how it gonna work. You can see that directions, right? So, okay, this is the screen. So from here we can measure the dimension. Okay, which of the following is used for measuring small gaps? So we have discussed a lot, right? So that is feeler gauge. Okay, you can see here in the image, this is the feeler gauge. It is used for measuring gaps between mating parts. Okay, it consists of a number of small length of steel strip of different thickness with measurements marked on each piece. Okay, double gauge is used for measurement of what? So it is option A, very short distance. Okay, a double gauge is used to measure very short distances. Okay, working principle of tail gauge is based on, it is based on rack and pinion mechanism. Okay, so you can see this is the dial gauge. It is one of the simplest and most widely used comparator. Okay, it is primarily used to compare workpiece against the master. Okay, it works on principle of rack and pinion. We discussed its least count is 0.01 mm or 0.0004 inch. Okay, I will write it down here. Least count is 0.01 mm or 0.0004 inch. Okay, optical gauge works on following principles. So that is reflection. Okay, how many pieces are there in working of general slip gauge? So it's an important thing you have to know, and that's the answer. Option C, 112. Okay, so there are 112 slip gauges in working of general slip gauge. Okay, 112. Okay, so these are the sets of slip gauges. Okay, So that's all about the chapter 3. We are moving to the chapter 4, micro measuring devices. Okay. So in that uh, first chapter is micrometer. Okay. And the first question is on dash in micrometer, the graduations is marked. So that is on thimble. Okay. On thimble in micrometer, the graduations are marked. Okay. You can see here in the image. Okay. So this is the thimble. So you can see the graduations are marked on thimble. Okay. So graduations are made on its beveled surface. Okay. And one part of thimble represents the least count of the micrometer. Okay. The size of micrometer and least count are written on the frame. Okay. And annual is fitted on the axis of the barrel at the left end of the frame. You can see here. This is the annual. Okay. So the nut is fitted by cutting the measuring face at one end of spindle and thread at the other end. Okay. So these are the different parts you have to remember. You may get questions directly. Okay. So please remember. A metric outside micrometer of range 100 to 125 mm is used to measure the diameter of a rod. Barrel graduation showed 14.5 and the thimble graduation line with the barrel datum line was 18. What is the diameter of the thread? Okay, here range given is range of micrometer, that is equals to 100 to 125 mm. Okay, so barrel graduation or my scale reading, we can say MSR equals to 14.50 mm. Okay, 14.50 mm. Okay, and the thimble reading, I'm writing it as THR. Okay, thimble reading. Okay, that is 18.0, sorry, 18 into 0.01. Okay, so that is equal to 0.18 mm. Okay, so we can write it 14.50 mm. So we'll combine this, we'll add this, sorry. So what we get? 14.68, right? 14.68 mm. Okay. So therefore diameter of rod equals to the range from 100, right? So 100 plus what we get 14.68 mm. So the final answer would be 114.68 mm. So the answer here is option C, right? Option C. Which of the following micrometer is more suitable for measuring the thickness of piping? That is tube micrometer. Okay, this is the micrometer. Okay, tube micrometer is more suitable for measuring the thickness of piping. Okay, tube micrometers have a cylindrical anvil positioned perpendicularly to a spindle. Okay, and is used to measure the thickness of the tube. Okay, what is the name of the part marked as X in the following figure? I have told you, right? So you may get questions of the part names. So here the X is anvil. Okay. So option A. You can see here in the image, these are the different parts I'm showing you again. Okay, please remember. Okay, so which pitch threads are cut on spindle of British system micrometer? That's option B, 1 by 40. Okay, the essential of a micrometer is an accurately threaded rod which can be turned in an equally accurate threaded guide. Okay, the usual pitch of the thread for instruments made for English measure is 1 by 40 minute. Okay, thus there are 40 threads per inch. Okay, which metal is used to make face of spindle and anvil of micrometer? So that is carbide tip. Okay, micrometer frame is made of. So micrometer frame is made of inward steel. Okay, option D. Okay, which of the following is a trapezoidal thread? So here the answer is acme thread. I'm showing you different types of profiles. Okay, so these are the screw thread forms. Okay, V thread, American National, Unified, Metric, Square, Acme. You can see this is the 29-degree. Okay, and with standard. Okay, knuckle, buttress. Okay, please remember the included angles. Okay, and formulas also given, right? P, I mean depth of the thread. Here for depth of the thread, I'm here mentioning here's a depth. Okay, depth of thread that is equal to 0.5 P plus 0.25. Okay, so this is for Acme thread. Okay, okay. How much is the included angle of a V belt? Okay, so it is 30 degrees to 40 degrees. Okay, you can see here in the image. Okay, this is the V belt. Okay, V belt drives are generally used when the distance between the shaft is too short for flat belt drives. Okay, its advantage is less vibration and noise. Okay, and also easy replacement and maintenance. Okay, name the part of micrometer that helps in maintaining uniform pressure on the job during measurements. So it's an important question, that is ratchet stop. Okay, you can see here in the image, this is the ratchet stop. Okay, so micrometer is to take the outside measurements are known as outside micrometers. The ratchet stop ensures uniform pressure between measuring surface. Okay, a micrometer is a precision instrument used to measure a job generally with an accuracy of 0.01 mm. Okay, and the ratchet stop or simply ratchet ensures uniform pressure between the measuring surfaces. Okay, keep that in mind. Okay, least count of vernier bevel protractor. So that is option D. Okay, 5 minutes. Okay, so the least count of bevel protractor is 5 minutes. It is commonly used for angular measurement. Okay, angular measurement, angular measurement. Okay, and where more precision is required, like for angular measurement in workshops. Okay, the vernier bevel protractor is a precision instrument meant for measuring angles to an accuracy of 5 minutes. That is 1 by 12 degree. That is 12th part of 1 degree. Okay, I'll write it down here. 1 by 12th degree. Okay, and that is 12th part of 1 degree. Okay. The least count of a metric micrometer is. So that is option B, 0.01 mm. Okay. So the least count of metric micrometer is 0.01 mm. Okay. Least count of any instrument is the smallest value that can measure accurately. Okay. We know that, right? A micrometer is an instrument for precise measurement of small distances. The sleeve, which moves in the spindle by turning it, is graduated with scale divisions that provide a measuring accuracy of 1 by 100, that is equals to 0.01 mm. Okay. Least count of vernier bevel protractor is. We discussed that, that is option A, 5 minutes. Okay. So these are the different least counts for the different instruments. Okay. Please note it down. Okay. I'll share the screenshot in the post section. Okay. Instruments with their least counts. Okay. Please go through it. What is the principle of micrometer? That is screw and nut. Okay. A micrometer works on the principle of screw and nut. Okay. It allows you an axial rotation of barrel-like structure, also known as thimble. Okay. Thimble are used to measure the distance of the object. Okay. And micrometer is a sensitive tool for making accurate measurements of linear dimensions. Okay. A micrometer has a negative error of 0.02 mm. If micrometer reading is 21.42 mm, then what will be the actual reading? Okay. So negative error in micrometer is 0.02 mm. Okay. So micrometer reading 21.42. So the actual reading I'm writing here, actual reading equals to micrometer reading. Okay. Micrometer reading plus negative reading. Okay. So we can get micrometer reading as 21.42 mm, 21.42 mm plus 0.02 mm, right? So we will get 21.44 mm. So option C, right? Identify the part A in the outside micrometer. So this is the part A. This is an anvil. Okay. We discussed that. Option C is right. Least count of outside vernier micrometer is. So that is option B, 0.001. Okay. Mm. Okay. One of the precision instrument used to check the dimensional accuracy of an V thread is a screw thread micrometer. Which one of the following element of screw thread micrometer? So that is pitch diameter. Okay. You can see here in the image, this is the screw thread micrometer. You can see that profile here. Okay. Mm, okay. And the sharp edge here. Okay. So screw thread micrometer is used to measure the pitch diameter and pitch of the thread directly. Okay. It is similar to ordinary micrometer. It is provided with contact point. Okay. It has two ends. One is connected with a spindle and another end has fixed anvil with corresponding recess. Okay. The spindle is in V shape, that is 55 degrees to British thread and 60 degrees for metric thread. Okay. Instrument used to measure diameter of circular stick case. So that is outside micrometer. Okay. So outside micrometer is used to measure the diameter of circular sticks. Okay. So this is the outside micrometer. Okay. And the parts. Okay. Micrometer works on the principle of nut and bolt or lead and pitch of screw. Okay. So the least count of it says 0.01 mm or 10 microns. Okay. It has single start Acme thread. Okay. Main scale is calibrated on sleeve or barrel, and ground scale is situated on thimble. Okay. And the pitch of screw thread is 0.5 mm, and number of divisions on thimble scale is 50. Okay. So we can find that least count by this. Okay. So least count equals to pitch. Okay. Pitch or lead. Okay. Pitch upon total divisions of thimble. Okay. Total divisions on thimble. Okay. So pitch is zero point 0.5, right? We had discussed 0.5 mm. Pitch of the screw thread is zero point 0.5 mm by total, and number of divisions on thimble scale is 50. So we can get 0.01 mm. Okay. This is how we're gonna get the least count. Okay. The depth micrometer is used for measurement of a wide range of sizes because it has number of extension rods for the different range of sizes. That is option B. Okay. The part of metric micrometer which carries the 0.01 mm graduation is called, that is thimble. Okay. So the part of the metric micrometer which carries the 0.01 mm graduation is called thimble. Okay. So you can see this is the micrometer, and these are the different parts of the micrometer. Okay. Frame is made of forged steel or cast iron. Okay. Barrel or sleeve. That is datum line is made here. Okay. You can see, just compare with the image. Okay. And thimble is it carries round scale and represents the least count of micrometer. Okay. And spindle, one end is measuring face and other end is threaded. Okay. Anvil is, it is made of alloy steel. Okay, you can see here this is the anvil. Okay. And spindle lock nut, use it to lock the spindle to take the reading. Okay. Ratchet stop, it is used to control the pressure. Okay. Name the instrument to measure wall thickness of hydraulic pipe. So that is tube micrometer. Okay. Tube micrometer is used to measure the wall thickness of hydraulic pipe or pipe shade workpieces. Okay. In its fixed annually situated at 90 degree from spindle. Okay. It is also known as span micrometer. Okay. Also known as span micrometer. Okay. Name the instrument to measure height of block step. So that is depth micrometer. Okay, you can see here in the image, this is the depth micrometer. Okay. It is used to measure the depth of bores, counter bores, rods, internal slots, and holes with accuracy. Okay. Depth can be measured along the large range by fitting in extension and or micrometer. Okay. An outside micrometer has graduations in the opposite direction. Okay. You can observe here in the image. Okay. And that's all. You have to remember the parts. Okay. Ratchet stop, same as the micrometer, thimble scale, barrel scale, reference plane. Okay. if I work as a blind hole like this, so the reference plane, that is base, is coincide with the top surface. Okay, so this is the height we wanna measure. Okay, which one is most precise? Scale, micrometer, that is micrometer. Okay, the least count of outside micrometer is, that is option C, 0.01 mm. Okay, the instrument used to measure the thickness of closely spaced section is, so that is internal micrometer. Option C. Okay, internal micrometer is used to measure the thickness of closely spaced sections. Okay, least count of internal or an inside micrometer is 0.01 mm. Okay, least count is 0.01 mm. Okay, and this micrometer does not have a frame. Okay, these micrometers can measure 50 to 60 mm without extension rod. Okay, determine the reading of the micrometer from the figure. So here main scale reading is how much? 6 and 7. So MS or main scale reading is equals to 7 mm. Okay. So thimble or round scale reading is how much? Okay, 31, right? I'll write it down. Thimble reading, that is 31 into least count, that is 0.01 mm. 0.01 mm. So that is equals to 0.31 mm, right? So the final reading is 7 plus 0.31 mm, that is equal to 7.31 mm. Option B. Okay, so thimble reading equals to coincide of the thimble line and the least count. Okay, please remember that. So option B is right. On an outside micrometer, calibration and datum lines are marked on the, so these are marked on the barrel. Okay. Reading of the following metric micrometer shall be. So same thing, we're gonna find main scale reading is 20 plus 1 graduation is there here. So that is main scale reading, that is 21 mm. Okay. And thimble reading equals to not 15, okay, 14. 14 into 0.01 mm. Okay. So that is equal to 0.14 mm. 0.14 mm. Okay. So the total reading equals to 21 plus 0.14. So that is 21.14. Okay. What is the answer? Option C. Okay. Option C is the right answer. Identify the micrometer shown in the figure. So it is an inside micrometer. Okay. Option B. Okay. This micrometer does not have a frame. Okay. Inside micrometer does not have a frame. I'll write down here. Have a frame. Okay. And one of its end has adjustable anvils and other end has fixed anvils. Okay. It has half inches spacing collar. It does not have a ratchet stop and frame. Okay. It is used extension rod for measuring. Its least count is 0.001 inches or a 0.01 mm. Okay, least count 0.01 mm or 0.001 inches. Okay, while taking reading by a dial indicator, if it is look from an angle rather than looking straight, then the indicator will show either low or higher reading. Which of the following shall be the error? Okay, here the answer is observatory error. Okay, so parallel error is found in dial test indicator scale and instruments. Okay, the reason for this is the distance between the scale and the indicator. Okay, if we look at the indicator from slant side rather than the looking straight at it, okay, then the indicator will show higher or lower reading. Okay, so there are different types of errors are there. I will discuss. Okay, I'll tell you. We'll discuss in the smart concepts. Okay, but now I will write down all the errors. Okay, first one is systematic error. Okay, systematic error. Okay, and the second one is geometric error. Geometric error, and the third one is random error. Okay, random error. Fourth one is instrument error. Okay, instrument error. And the fifth one, parallel error. Okay, and the sixth one, temperature error. Okay, temperature error, and the seventh one is contact error. Okay, eighth one is observation error. Okay, ninth one is elastic deformation error. Okay, tenth one is cosine error. Okay, okay, these are the types of errors. Okay, we will discuss in detail in the coming classes. Okay, identify the part X of micrometer from the figure. So it's easy one, that is ratchet stop. Okay, option B. Okay, so these are the different parts of the micrometer. Okay, please remember this. You may get questions from this. Okay, what is the zero reading of 50 to 70 mm outside micrometer? So the micrometer range of measuring size is 50 to 70 mm. Okay, the zero reading of it is 50 mm. Okay, so option D. Okay, so you may get confused. Here they're giving the 50 to 70, right? We will take 25 to 50 mm range. Okay, so here the zero reading is 25. Okay, so the first reading is considered as zero reading. Okay, the meaning of zero error in a micrometer is, so it is option D. When the measuring face is in contact and zero on the thimble and zero on the datum line do not meet each other. Okay, that's called zero error. Okay, so these are the different types of errors. Okay, here if you see in the first picture, zero and zero coincides. So there is no errors. Okay, 0 on the thimble and 0 on the datum line coincides, then there is no error. Okay, if you see here, 0 is here and 0 on the thimble, that is uh, somewhat down, right? So it is positive 0 error. Okay, and here if you see that 0 is here and 0 on the thimble line, that is somewhat forward, I mean upside. So it is a negative 0 error. Okay, so 0 errors when the measuring face is in contact and 0 on the thimble and 0 on the datum line do not meet each other. Okay, up to that, everything clear, right? So on the thimble coincides with the 0 mark on the datum line near the datum line, then there is no 0 error. Otherwise, there is a 0 error. Okay. The ratchet stop in micrometer helps in. So it helps in controlling the pressure. Okay. Now the ratchet stop in a micrometer helps in controlling the pressure. Okay. Ratchet stop maintain a uniform pressure on micrometer during measuring with the ratchet stop. Okay. So there is a negative error of 0.03 mm in a micrometer if the micrometer gives a measurement of 40.53 mm, then what will be the correct reading? So here micrometer reading is 40.45, right? Micrometer reading that is equals to 40.53 mm. Okay, 40.53 mm. Okay, and the negative error here, negative error that is equals to 0.03 mm. Okay, so correct reading of the micrometer equals to reading and I mean plus negative error. Okay, so correct reading of micrometer. Okay, equals to micrometer reading. I'm considering it is MR plus negative error. Okay, so that is 40.53 plus 0.03. So here the final answer is 40.56 mm. Okay, so option B, right? So I will write down the contact readings. Okay, so note contact reading of micrometer. Sorry, correct reading. Sorry, correct reading equals to micrometer reading plus negative 0 error. Okay, negative 0 error. Okay, and the second one is correct reading equals to micrometer reading minus. Okay, minus positive 0 error. Okay, okay. How to find that whether the given error is positive or negative? Here we mentioned that negative errors. So that's why we have taken the positive sign here and we're adding the error. Okay. There is a positive error of 0.02 mm. So here you can see they are mentioning that positive error, right? So micrometer gives measurement of 25.41 mm. So micrometer reading MR we can say that is 25.41 and positive error, okay, that is 0.02. So what is that formula for correct reading? Correct reading equals to micrometer reading minus positive error, right? So here the answer would be 29, sorry, 25.39, right? 39 mm. So option A, okay? Option A is right answer, okay? What is the value of micrometer setting in the following figure? Okay, you can see here the main scale reading. This is 0, 1, 2. So main scale reading is 2 mm. Okay, and the thimble reading that is equals to 30, 31. Okay, 31 into 0.01 mm. So 0.01 is placed count. So 0.31 is thimble reading. Okay, so final reading that is total reading equals to 2 plus 0.31. So that is equals to 2.31 mm. Okay, so that is option B. Okay, so same thing. So here main scale reading equals to 10, 10, 11, 12. Okay, 12 mm. Sorry, 12.5. Okay, 12.5 mm main scale reading. Okay, so you can observe that one downward also there, right? Downward line coincides with the thimble. Okay, so thimble reading equals to thimble reading, it is coincides. Okay, it is 19. 19 into 0.01 mm, right? That is equal to 0.19. Okay, mm. So here total reading equals to 12.5 plus, sorry, plus 0.19. Okay, so 12.69, right? Option A is right answer. Okay. In which of the following micrometers the graduations of thimble and sleeve are made in opposite direction with respect to an outside micrometer? We have discussed that that is an depth micrometer. Okay. You can see here in the image, this is the depth micrometer. Okay. In depth micrometers, the graduations of thimble and sleeve are made in opposite direction with respect to an outside micrometer. Okay. Identify part X. So this part they are asking, what is that? That is an thimble. Okay, option B, right? Yeah, option B is thimble. In an external micrometer, the face and spindle of anvil is made of the following. So the answer is tungsten carbide. Okay, so I will write in down here the face and spindle made of tungsten carbide. Okay, carbide or high carbon steel. Okay, high carbon steel. Okay, and the frame is made of cast iron or forged steel. Okay. Okay. The micrometer works on the principle of nut and bolt. Okay. So the linear distance traveled by a spindle in one round is equal to the pitch of the screw. Okay. The screws used in micrometer is single star, threaded, and Acme thread. Okay. So the micrometer works on the principle of screw and nut, or a nut and bolt. Okay. Principle. Metric micrometers are available in the range of. So there is option A, 25 mm. Okay. So a range of 25 mm is marked on all micrometers such as 0 to 25 mm, right? So 50 to 75 mm, okay? 75 to 100 mm, so 100 to 125 mm, 125 to 150 mm. Likewise, so you can find that range is 25 mm, right? So for every metric micrometer, the range would be 25 mm. Okay, range. Okay, there is an error in the outside micrometer. An accurate reading can be taken by. So here, adding negative error to actual reading. So we have discussed that formula, right? So first one is right answer. So I will write it down here, but before that, say this. So zero error, positive errors, and negative errors. We have discussed that, right? So um, correct reading, that is we correct reading equals to micrometer reading minus positive reading. Okay. So one more thing, correct reading equals to micrometer reading plus negative reading. Okay. In a vernier micrometer, vernier scale is graduated on. So vernier scale is graduated on barrel. Okay, option C. The value of one thimble scale division in metric micrometer is, so that is 0.01 mm. Okay. The faces of anvil and spindle of outside micrometer is made of, we have discussed, that is tungsten carbide. Okay. The zero checking is done for 0 to 25 mm depth micrometer on a, it is on a surface plate. Okay. The zero checking is done for 0 to 25 mm depth micrometer on a surface plate. Okay. So while the zero error of 50 to 75 mm outside micrometer can be checked with the test piece. Okay. So 50 to 75 mm outside micrometer. Okay. Outside micrometer can be checked with test piece. Okay. Test piece. Okay. Outside. Okay. The smallest inside micrometer has the graduation mark on the sleeve to a range of. So that is option C. Okay. 13 mm. Okay. Micrometer height. It consists of a sleeve, a thimble, and an anvil locking screw for extension rod. Okay. The smallest inside micrometer has the graduations marked on the sleeve to a range of 30 mm. Okay, so inside micrometer can measure half inch because it has half inch spacing collar. Okay, thus this micrometer can measure smallest value of 13 mm or half inch. Or okay, a micrometer has positive error of 0.02 mm. Okay, and what is the correct reading when the micrometer measures 25.41? So here main scale reading equals to 25.41 mm. Okay, so positive error. Okay, that is 0.02 mm. Okay, so correct reading equals to, we have to subtract. Okay, so that is 25.39. Okay, 25.39 mm. That is option A. Okay, zero error of 50 to 75 mm outside micrometer can be checked with. We discussed that, that is with a test piece. Okay, okay. While depth micrometer's zero error can be checked by surface plate. Okay, the value of the smallest division on sleeve of metric outside micrometer is, that is 0.5 mm. Okay, the value of smallest division on sleeve of a metric outside micrometer is equal to pitch of screw, that is 0.5 mm. Okay, the screw of micrometer has single start and acme threads having a pitch of 0.5 mm. Okay, if the zero graduation of the thimble division of an outside micrometer is below the datum line when the measuring faces of the micrometer are encountered, the error is. So the error is positive error. Okay, you can see here in the image. So this is the positive zero error. Okay, so thimble scale reading is below the datum line, right? So you can see this is below the datum line. Okay, this is the datum line. This is thimble. Okay, so this is below. Okay, this is below the datum line. So this is considered as positive zero error. If it is above the datum line, that is negative. Okay. If it is coincides, then no error is there. Okay. A depth micrometer can be used to measure wide range of sizes because it is equipped with a number of extension rods. Okay. So a depth micrometer can be used to measure wide range of size because it is equipped with number of extension rod. Okay, its zero error can be checked with surface plate. Okay, we discussed that. Metric outside micrometer has a threaded spindle with a pitch of 0.5 mm. Okay, zero error in micrometer means, it means zero on thimble and datum line on sleeve do not coincide when measured faces are in contact. Okay, an outside micrometer has a negative error. The correct reading can be taken by, so that can be taken by adding the negative error in the actual reading. Okay, we have discussed that formula, right? In a metric micrometer, a complete revolution of thimble advances, that is 0.5 mm. Okay, so in metric micrometer, a complete revolution of thimble advances 0.5 mm in axial direction. Okay, A micrometer has negative error 0.03 mm, shows a reading of 25.52 mm, the correct reading. So the correct reading equals to, so here mentioned 25, so we have to add it. 25.52 plus 0.03, that is 25.55, right, mm. So option B. Okay. What is the part used to change the range of depth micrometer? So that is extension rod. Okay. The depth micrometer consists of a stock on which a graduated sleeve is fitted. Okay. The extension rod is used to change the range of depth micrometer. These extension rods can be inserted inside the thimble and the sleeve. Okay. So the extension rod may be removed and replaced according to the size of depth to be measured. Okay. Which inside dimension is not possible to measure by the inside micrometer. So that is option A. Okay. So why 10.45 mm is less than half or half inch or 13 mm, right? So 10.45 is less than 13 mm. Okay. 13 mm or half inch. Okay. Write the reading of 0 to 25 mm micrometer setting shown in the figure. So here main scale reading equals to how much? 5, 6, 7. Okay, 7 mm. Okay, and thimble reading is 31. Okay, 31 mm into least count, that is 0.01. Okay, that is equal to 0.31 mm. So total reading would be 7.31 mm. Okay, so option D is right answer. Okay, if zero graduation of the thimble is above the datum line when the measuring places are in contact, the error is, that is negative error. Okay, we discussed a lot, right? So if you observe, this is the zero of datum. Okay, so on thimble it is above. Okay, zero is above the datum line on thimble. Okay, so if they ask, if they ask that zero is below the datum line, that is positive error. Okay, if it coincides, there is no error. Okay, name the part marked X in figure. So here X is that is thimble. Okay, name the division marked X indicate. So that is vernier graduations. Okay, okay. So there are 10 vernier graduations parallel to the datum line. Okay, there are 10 like parallel lines. Okay, okay, there are total 10, 0 to 10. Okay, there are 10 vernier graduations parallel to the datum line. Okay, there are 10 vernier graduations equal to 9 graduations of thimble. Okay, this is thimble, right? So I will write it down when I get confused. Okay, the first point, there are 10 vernier graduations parallel to the datum line. graduations parallel to the datum line. Okay, and there are 10 linear graduations equal to 9 graduations of the thimble. Okay, 10 linear graduations equal to 9 graduations of thimble. Okay, and the value of one graduation of veneer is 0.009 mm. Okay, the value of one graduation of veneer. Okay, one veneer is 0.009. Okay, mm. So the value of one graduation on thimble is 0.01 mm. Okay, and the least count of veneer micrometer is 0.001. Okay, least count of veneer micrometer is 0.001. Okay, name the instrument to measure the diameter of round rod. So that is outside micrometer. Okay, so inside micrometer is used to measure the internal diameter of hole. Okay, and depth micrometer is used to measure the bore depth. Okay, I'll write it down here. Yes. It is bore depth. Okay, inside is internal diameter of hole. Okay, diameter of hole. Okay, tube micrometer. Tube micrometer is used to measure the sheet thickness and wall thickness of pipe or a tube. Okay, sheet thickness and wall thickness of pipe or tube. Okay, pipe or a tube. Okay, the degree of repeatability of an instrument is expressed by, so that is known as precision. Okay, the smallest magnitude which can be accurately measured using any measuring instrument is called, so that is least count. Okay, the instrument used to measure the thickness of closely spaced sections is called, so that is internal micrometer. The instrument used to measure the thickness of closely spaced sections is internal micrometer. Okay, so this is the 3 point internal micrometer. For example, I'm giving. Okay, so this is how we're gonna measure the internal diameter of a ring or a hole. Okay, so this is 3 point. You can see the 3 points. Okay, this is a 3 point internal micrometer. Okay, so number of graduations on the thimble of a metric micrometer, that is 50. Okay. Number of graduations on the thimble of a metric micrometer is 50. The part of the metric micrometer which carries the 0.01 mm graduation is called. It is called thimble. Okay. The diameter of finished turn shaft can be checked with a it can be checked with the outside micrometer. So here micrometer mentioned. So outside micrometer. Okay. Outside micrometer. Okay. Determine the least count when one main scale equals to 1 mm and one vernier division equals to 9/10. So least count equals to one main scale value. Okay. 1 MSD main scale division minus 1 VSD. Okay. Vernier scale division that is equal to 1 mm minus 9/10 mm. So that is equals to 1/10 mm, right? 1/10 mm. So it's equal to 0.1 mm. So option B. Okay. For measuring the holes with a diameter greater than 50 mm, which one of the following instrument is preferred? So that is internal micrometer. Okay. For internal measurement with an accuracy of 0.01 mm, which one of the following instrument is preferred? So that is internal micrometer. Okay. Screw thread micrometer is used to measure pitch diameter. Option B. Okay. So screw thread micrometer is used for measuring the diameter for pitch of the thread. Okay. This micrometer is similar to an outside micrometer. Okay. The only difference is that its spindle and anvil are made at 60-degree angle in order to fit on the V thread. Okay. This micrometer are available in many sizes according to the pitch of the threads. Okay. Which one of the following parts is used for locking the micrometer at any desired setting? So that is spindle clamp. Okay. Which type of micrometer having the advantage of readings are seen in the screen or dial directly? So that is digital micrometer. You can see here in the image that is the digital micrometer. So you can see the readings directly on the screen. Okay. So advantages of the digital micrometer are fast reading as the reading is displayed. Okay. Lower error, it eliminated human error. Okay. Easy conversion, zero setting made easy at any point. Okay. Transferable data. Okay. The checking born with 3-point internal micrometer, the type of error detected is. So that is macro geometrical error. Okay. The checking born with 3-point internal micrometer, the type of error detected is macro geometrical error. Okay. So that's all for today. Thank you.